Number 23, notice that the exponential problem is not alone and has that 3 there. So the first thing we want to do is get it alone by adding a 3 to both sides. We then end up with 5 to the x plus 4 equals 21. Now, to get that x out of the power, we have to get rid of the base. And to get rid of the base, we could take the log of both sides, but we have to make sure that it's log base 5 so that the log base 5 and 5 will cancel out. And then over here I've got to squeeze in another little log base 5. So the log base 5 and 5 cancels out, and we just have x plus 4 equals log base 5 of 21. Then, last step to get the x alone, we have a minus of 4 from each side. Then we would just grab a calculator and put that in. And just take the log base 5, and if you know how to change the base on your calculator, that would be great. If not, you have to do the change of base formula. So log base 5 of 21 minus 4 gives us an answer of 1.760. Number 24, the first thing you should notice is this 13 is being multiplied by the x, or the e to the x minus 5. So if we divide each side by a 13 and get rid of that 13, we get 2 equals, I'm going to leave a little space here, e to the x minus 5. Now, to get rid of the e, I have to take the natural log, because natural log is log base e. So I take the natural log of that side also. Then I end up with natural log of 2 equals natural log, and e cancels each other out, so I just get x minus 5 then I need to add a 5 to both sides to get the x alone. And my final answer would then be x equals natural log of 2 plus 5. And when you grab a calculator, you go natural log of 2 plus 5, and the answer is 5.693. 5.693. Number 25, natural log of 2x minus 4. So I'm going to start by getting rid of that natural log by raising everything to the power of e. So now the e and the natural log cancels each other out, and I have 2x minus 4 equals e squared. To get the x alone, I've got to add a 4 to both sides. So I'm going to add a 4 over here. And then I have this 2x that I need to divide by a 2, divide that by a 2. So we get x equals e squared plus 4 divided by 2. And then you grab a calculator and put that in. E to the power of 2 plus 4. And then I'm going to hit equals so that I have that answer and divide the whole thing by 2 just to make sure it's all being done right. And the answer is 5.695 if we round it to 3 decimal places. Some more solving problems. So here's the x right here. It has this plus 9, and then the log, and then this minus 6. I'm going to start by getting rid of the 6. I want to get the log function alone. And then notice this 3, if I change this to a power, so it would be log base 5 of this quantity of x plus 9 to the third power equals 6. My next thing to get rid of would be this log base e. So if I raise everything to the power of 5, then 5 log base 5 that's going to cancel out. And then I have a 5 over here. The 5 log 5 cancels out. I have x plus 9 quantity to the third power equals s to the 6th, or 5 to the 6th. That's a 5, isn't it? And instead of multiplying that all out, I'm going to take the third root of each side so I can get that x alone. So if I take the third root of this over here ends up to just be x plus 9. And the third root of 5 to the 6, you could think of this as being 6 divided by 3, so you end up with just 5 squared. Then if we minus a 2, we have x equals 5 squared is 25, minusing the 2 from both sides, and our final answer is x equals 23. Now one thing I forgot to mention on these is to check to make sure that you don't have any extraneous solutions. So let's check on this one. 23, if you put it back in here, is still a positive number. The big thing to watch out for is if you get any negatives. Then that would make the solution undefined. Alright, now this one over here, we have log base 6, log base 6, they're being added together. I don't want 2 logs, so I want to contract those together. So we have log base 6, and then I multiply the x and the x minus 5, and that whole thing is just equal to 2. Then to get rid of the log base 6, I'm going to raise everything to a power of 6. So this 6 log base 6 cancels out. I just get this. I'm going to go ahead and distribute that. So it's x squared minus 5x equals 6 squared, which is 36. Now I have an x squared and an x. I'm trying to solve for x, so that's kind of a big hint that I need to get them all on the same side, everything, and factor. So I have x squared minus 5x minus 36 equals 0. I'm going to do the x gains of negative 36 and negative 5, and then I think what multiplied together gives me this and added gives me this. And I know that a negative 9 and a positive 4 multiplied would give me negative 36, added would give me negative 5. So I have x minus 9 as my one factor, and x plus 4 as my other factor, which then makes the solutions x equals 9 and negative 4. Now the negative 4 kind of gives me a caution that I'm going to have some problems with that, and it does right here. Log base 6 of negative 4 would give me an undefined value, so negative 4 does not work. 9 will not give me any negative numbers, so that one does work. So that's my answer. Number 28, we have a log on this side and a log on that side. We can't solve it unless there's just one log on one side. So I'm going to subtract this. So I get this log base 3 of 2x plus 3 minus, because I'm subtracting it from both sides, log base 3 of 6x plus 4. X plus 4. Now, because they're being subtracted, that means I then rewrite, I'm going to contract them together. So this is log base 3 of 2x plus 3, all being divided by 6x plus 4. And that whole thing is equal to 0. To get rid of the log base 3, I'm going to raise everything to the power of 3. The 3 and the log 3 cancels out. I just get this 2x plus 3 over 6x plus 4. equals, well, 3 to the 0 is just 1. Anything to the 0 power is 1. Now I have a problem, a rational problem, and I want to get rid of that denominator. So I'm going to multiply both sides by 6x plus 4 so that that denominator cancels out over here, and over here I have 6x plus 4. Now I have this 2x plus 3 equals 6x plus 4. I'm going to minus a 2x from each side and get a 4x. And then I'm going to minus a 4 from each side and get negative 1. Then when I divide by 4, my answer is x equals negative 1 over 4. There we go. Number 29. We are going to use this equation right here. So T is the temperature after 2 minutes, and you want it to be 100 degrees. That's the temperature you're waiting for it to cool down so you can eat it. The initial temperature, or when you're starting the cooling down phase, is 212. We are minusing the temperature of the room, which is 72 degrees, and this is multiplied by e to the negative. R is 0.046, and T, our time, that's our unknown. And then we have to add in the temperature of the room. So first thing I'm going to do is get rid of that 72 from both sides. And 100 minus 72 is 28. I'm going to subtract these numbers in the parentheses. And 212 minus 72 is 140. And then I have this e to the negative 0.046 times t. Getting rid of the 140 by dividing both sides by 140. 28 divided by 140, and 40 is 0.2 equals e to the negative 0.046 t. Now to get rid of the e, I'm going to take the natural log of both sides. So I end up with a negative 0.046 t equals the natural log of 0.2. And my last step, I'm going to divide by this negative 0.046 to get the t alone. I grab a calculator and I put in natural log of 0.2. Find an answer, because I always like to do that just to make sure I'm doing the steps right. And divide it by that negative 0.046, and you get 34.98. So what this says, about how long do you have to wait? That would be about 35 minutes for your soup to cool down enough to eat.